Good morning, good afternoon, good evening, whatever the case may be, we are back and better than ever. And that shooting star is mathematics, and today it is the continuation of geometric sequences. Let's get to it, shall we? Looking to me, we'll check back in with that, Gus Smith. Looks to me like we will finish up geometric sequences, at least laying the base for it, the groundwork right here. Let's get to it. Geometric sequence has use of 2 equal to -6 and use of 5 equal to 162. Find its general term. And recall, this is in your formula booklet as well. U sub n is equal to U sub 1 times r to the n minus 1. U sub n, of course, is the first term, which we need to find, and r is the common ratio. So here we go. So U sub 2 equals -6. U sub 3 is going to equal -6 times r. U sub 4 is equal to -6 times r, which is -6r squared. And U sub 5 would be equal to -6 times r times r times r, or -6r cubed. Recall, for a geometric sequence, like, I don't know, 2, if we multiply by 3, so that would be 6, 18, 54. To get to 54, I do 2 times 3 times 3 times 3, so 2 times 3 cubed. So that's where we're getting this r times r, and r times r times r. Now, we also know that the fifth term is 162. So I have -6r cubed is equal, excuse me, to 162. And just trust me on this, if I divide 162 by -6, I get -27. So I take the cube root of -27, and I get my common ratio, boys and girls, -3. Okay, so I have my common ratio, boom, right there. All I need is U sub 1. So remember, let's just think about this real quick. U sub 2 equals -6, correct? And so U sub 3 would be equal to -6 times the common ratio, -3, which is 18, right? So, but we need U sub 1, okay? So if I'm multiplying by -3 to move to the right along the sequence, and that's kind of the sequence, I kind of got lucky there, but we got a -3. To move backwards, I would divide by -3 or multiply by -1/3. Same thing. So 18 divided by -3 is -6, and -6 divided by -3 is equal to +2. So I've got my U sub 1, meaning my general term is U sub 1 is equal to 2 times -3. That's I don't need that multiplication symbol. -3 to the n minus 1. Boom! All right. Now, these parentheses here are very important because I'm raising this to this power, and the negative is included. Just to reiterate, this is not equal to this. Okay? Reason being, here the negative is included when I consider the exponent. Here the negative is not included. This is 3 to the whatever, and then it's negative. Here we use the negative in the calculations when using whatever exponent goes here. All right, get your calculator out. Find the first term of the sequence, blah, 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 which exceeds 1400. All right, so U sub n equals U sub 1 r to the n minus 1. Clearly, U sub 1 is equal to 6, right? R, I take any term and divide it by the previous term, so 12 root 2 divided by 12 is equal, I should say R equals, which is equal to kapow root 2. So this is 6 times root 2 to the n minus 1. I don't need parentheses here because this doesn't include a negative. So I don't have to use the parentheses if I don't want to necessarily. Okay, so this is a bit nasty here. We could use logarithms, so we need to see which one exceeds 1400. 1400 would be equal to 6 root 2 n minus 1 and divide by 6. So 1400 over 6 equals root 2 n minus 1. Take the natural log or log of both sides. If you forget logs, not to worry, we will be discussing them again in this course. And from the rules of logarithms, if you take, or no, not to take, this is an equivalent to move the exponent out in front, ln root 2. And so now we're going to divide both sides by the square root of 2. And that would give me, I'm sorry, not the square root of 2, the natural log of square root of 2. So I have the natural log of 1400 over 6 all over the natural log of root 2 equals n minus 1. So I add 1 to both sides and I get natural log of 1400 over 6 over natural log of root 2 plus 1 is equal to n. Now, that's pretty nasty. It's not too bad if you know your logarithms, and again, don't worry if you're a little bit rusty. We'll talk a lot about it in class. And there's another way on the calculator, so if it is a GDC question, you'll be able to use your GDC a little bit easier, and of course you're going to need it for this anyway. Okay, so I have the natural log of 1400 over 6, and all of that was divided by the natural log of the square root of 2. And then, if you remember, we added 1, boom, chugga-lugga-lugga, and there we get 16 point something, I forget. Let's take a look. Boom. Okay. Make that a little smaller for our purposes. All right, so we have to interpret this answer here. It says the first term of the sequence. Which term number does it? Well, it's not term 16 because it took 0.7 to get to 1400, so it has to be the 17th term. Now, in this equation, n equals 16.7, but when we consider n being a term number, it must be the 17th term, or n equals 17, I should say. And u sub 17, if you crank it into this formula, I won't bore you, it would be 6 times root 2 times 17 minus 1, or root 2 times the 16 to the 16th power times 6. And that turns out to be 1,536. Okay, so now let me show you how you can do it on your calculator. Pretty cool here. Okay, so we're going to graph it. I'm going to go ahead and set my scale already. I already know that it's 17. So I'm going to go 0. I'm going to go up to 2,000. I'm going to go, I don't know, out to maybe 20. And that looks pretty good there. And then I'm going to graph the original function here, which is the function for the sequence, 6 times square root 2, 2. And that is to the, using the caret, n minus 1, but on the calculator we have to use x. Bam. Okay. And then I can graph the function f of x equals 1400, right? And so that graphically shows me the x value where it equals 1400. So I can find the intersection and analyze graph, intersection to the left, to the right, and I get my 16.7 there. So from there, I can see that it'll be the 17th term. Okay, the other way you can do it is using a table. And if I say go to menu again, table, and do a split screen table. Watch this. Okay, so look what's happening here. The first term is 6. The second term is 8.48 about. The third term is 12. So I can just keep scrolling down until I see where I exceed 1400 and I can get the term. And you can see at the 16th term it equals 1086 and the 17th term equals 1536. So I've just shown you 3 ways that we can solve this problem. Okay, let me pop that on there for our notes. Oops, I have to do it this way. So partial, boom, boom, and let's scroll down, give myself a little more room and make it a little smaller. But you can see from our x-intercept here and from our term number that it is the 17th term. So any of those ways you can do it. I would say if you have your calculator, clearly the best way is this. Okay. All right. And so that's going to do it. Looks like we need a part 3. And that'll be a quick one. But for now, I am out. You make what doesn't matter fade too great.